Welcome back, my dear students. In the last session, we have learned part 1 of chapter number 6, square and square roots. Today, let us learn part 2 of chapter number 6. Exercise 6.1, question number 7. Let's study the question. Without adding, find the sum. Here the question says that without adding the numbers, this is plus sign, this is plus sign, this is plus sign, this is plus sign. Without adding these numbers, we have to find out the sum. So now solution. 1 plus 3 plus 5 plus 7 plus 9. Here we are going to apply adding odd numbers. 1 plus 3 is equal to 2 square. 1 plus 3 plus 5 is equal to 3 square. 1 plus 3 plus 5 plus 7 is equal to 4 square. 1 plus 3 plus 5 plus 7 plus 9 is equal to 5 square. Here, if we add two consecutive odd numbers, that is 2 square. If we add 3 consecutive odd numbers, 1, 2, 3, then 3 square. If we add together 4 consecutive odd numbers, 1 plus 3 plus 5 plus 7, 1, 2, 3, 4, then 4 square. If we add together 5 consecutive odd numbers, 1, 2, 3, 4, 5, then 5 square. We have to use this. Here, we are adding 1 plus 3 plus 5 plus 7 plus 9. And let us count how many odd numbers are adding. 1, 2, 3, 4, 5. Here, 5 odd numbers are adding, so this is equal to 5 square. And we know that 5 square is 5 into 5, that is 25. So, the sum of these odd numbers will be 25. Here, this question 1 is over. I hope you can understand this. Then next, Roman number 2. And this also same. 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19. Here, let's count how many odd numbers are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 odd numbers. And this will be equal to 10 square. 10 square is 10 into 10, that is 100. And this is the answer. Next, Roman number 3 is same, so you practice Roman number 3. Now let's try question number 8. Express 49 as a sum of 7 odd numbers. This also same as question number 7. (49) is equal to express 49 as a sum of 7 odd numbers. Here the question says that this 49 we have to express as a sum of 7 odd numbers. So the first odd number is 3, next odd number 3, next odd number is 5, next odd number is 7, next odd number is 9, next odd number is 11, and next odd number is 13. So plus sign. So in the bracket 1, 2, 3, 4, 5, 6, 7. Sum of the first seven odd numbers. If we add together the first 7 odd numbers, then 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13. Here the odd numbers are 7. 1, 2, 3, 4, 5, 6, 7. And this will be equal to this 49. Yani ko se gyan tari ko mathang tauge. Roman number 2, express 121 as the sum of 11 odd numbers. This question is same as Roman number 1. 121. Here this is sum of 11 odd numbers. Sum of the first 11 odd numbers. And this is equal to, first odd number is 1, next is 3, next is 5, next is 7, next is 9, next is 11, next is 13, next is 15, next is 17, next is 19, and next is 21. And sum means plus, so here plus sign. Plus, 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 and plus, and plus, and plus. And these are the first 11 odd numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And this is the answer. Matang question number 9 is how many numbers lie between square of the following numbers 12 and 13? Sida hujik question is 12 square si putoba aduga 13 square si putoba mabani gi difference kaya tagadagi haba. How many numbers lie between square of the following numbers? Mahada piriba number anisigi square putopa agati sigi number anisigi marakta number kaya laigadagi haba. So to solve this, let us remind one formula. A plus B whole square. Sigi formula sa utang nisa hanggang yang si A plus B whole square sumalai A square plus twice AB plus B square. Sigi formula si kangi ko. Sigi formula si palaga hoje sumai yang ani. Sigi formula si palaga si utang whole yang si n plus 1 whole square minus n square si. Sige n plus 1 whole square da sige formula se palani n lay bagi n square lani plus 2 times of a gi n lakani b gi 1 lakani plus b square si 1 square oini mathang da minus n square la halani sige n square ga sige n square si amana minus ni ani si cancel sakha ga 0 tare sida multiply laire sida multiply laire sige singse plus 2 into n into 1 di 2n tarni plus 1 square di 1 tare adu tardi n plus 1 whole square minus n square si silani sige sida koina sige n sige mota 12 thamba targa di sumai lakani 12 plus 1 sina n sina koin karigumba 12 thamba targa di 12 plus 1 whole square lakani minus n si 12 ni square sumai lani adaidi saida 2n lakai tardi 2 into sigi 12 si lani plus sigi 1 si lakani sain toroga loi tardi 2 into 12 is 24 lakani plus 1 24 ga 1 ga plus tardi 25 tare adu sigi si koin 12 ga 1 ga plus tardi 13 lakani 13 square minus 12 square haina adu di hauji sigi se among yenga si se 12 square minus 13 square saigi roman number 1 da pirisi amana 12 ni amana 13 ni question si da haisina 12 square ga 13 square ga gi number ani du gi marakta number kaya lai bagi asini adu tardi saigi 12 tu si laire amana 13 si laire adu tardi sigi formula si sinani n plus 1 whole square minus n square is equal to twice n plus 1. Sige, sina ni gyan tayo ko. Now, solution. Since n square and n plus 1 whole square data between numbers sithare between since between n square and n plus 1 whole square there are 2n non-square number lies. Sige si textbook ta yaw bani sai ta yaw se page number 93 ta Sigise. There are 2n non-perfect square numbers between the square of the numbers n and n plus 1. N square amasung n plus 1 square gi marakta 2n non-perfect square number laigani haiba sigisini aina sidaida palise. Since between n square and n plus 1 square there are 2n non-square number lies. Numbers lie. Roman number 1 kita orsi Roman number 1. Between 12 square and 13 square there are sigi 2n si lakado 2 into sigi n si di 12 si tarani 2 into 12 numbers, and this is called to, if 2 and 12 are multiplied, then we are getting 24 numbers tare sida loire gyan tare ko yar ko si se Roman number 2 du ka tausi 25 and 26 si manare sani rani between 25 square and 26 square there are 2 into number masa si logani 25 numbers 2 into 25 ti 50 tare 50 numbers tare si yarni ko gyan tare ko Roman number 3 du manare adu practice tawro next di Pythagorean triplet si kaino haibsi ongtang khanara yengsi triplet haibdi 3 habdi 3 habni aduna triplet haina haisi 3 numbers tagi lapa haibdi number si ahum number ahum oigadoba adu itardi hoji ahambada akoi number khara hoji khanarasi 3 haibamne 4 haibamne aduga 5 haibamne khanaraga yengsi 3 4 5 se by number 3 si square hoji puthosi sidaida plus option si sigi second number 4 square siga hoji plus aure 3 square si 9 ni 4 square di 16 ni 9 ga 16 ga plus okanda 25 tare hoji ahom subda lehori ba third subda lehba number 5 square si amu yengsi 5 square 5 square di 5 into 5 ni adu di 25 tare adu di hoji sigi 25 ka sigi 25 ka si manare adu na hoji khoina kari khangage hakanda 3 square plus 4 square is equal to 5 square tare aduna khoina hoji sidagi hoji kramaina lakpa yage hakanda number se khoin ahum lorkanda first number gi square ga second number gi square ga adugi plus tawbadu third subda number du gi square du ga manam targa di sigi piriba number ahum se habdi 3 4 5 se kari haina khangna ge hakanda Pythagorean triplet haina khangnai. Then the collection of numbers 3 ne comma 4 ne duga 5 ne sigi number hum sibu kari haina khangna ge kan the Pythagorean triplet ha khangni is known as Pythagorean triplet. Pythagorean triplet. These 3, 4 and 5 we can write as 4 first, then 3 after that 5. Again, this number 4 we can write as 2 into 2, and this number 3 we can write as 2 2 square minus 1, and this number 5 we can write as 2 square plus 1. If this 2, if we replace by m, then we can write as like that. 2 into 2 will be now 2m, and this 2 is now m square minus 1 and m square plus 1, m square plus 1. Here we see that 3, 4, 5 are Pythagorean triplet. Then 4, 3, 5 is also a Pythagorean triplet, and this number also a Pythagorean triplet, and this also a Pythagorean triplet. So this is the formula to find out Pythagorean triplet. Is a Pythagorean triplet. So we can write this as like that. For any this m is greater than 1, this 2m m square minus 1 and this m square plus 1 form a Pythagorean triplet. So if we want to form Pythagorean triplet, then we will use this as the formula to form a Pythagorean triplet. Now let us start exercise 6.2. Exercise 6.2, question number 1. Find the square of the following numbers. Here the question says that to find out the square of the number Roman 1 32. Now solution. 32 square is equal to sign. This 32 we can write as 30 plus 2. Here is part 2. And this 30 plus 2 whole square, again we can write as 30 plus 2 into 30 plus 2. Gyan tai ko sidagi sida lai se. Sidai the part 2 lai re, part 2 later this same number si 2 times iraga koina multiply tawni. Mathang da multiply si first number na sigi bracket ta kantorani multiply tawni. First number na sigi bracket haibadi 30 plus 2 da multiply. Mathang da sigi plus 2 na sidai da mo multiply tawni. Sida koina policy distributive law ni. Mathang da 30 into 30 lakani. 30 into 30 plus 30 into 2. 30 into 2 plus 2 into 30 plus 2 into 2 sumai lakani. Gyan tai ko se 30 into 30 di 3 3 are 9 0 ni lakani plus 30 into 2 di 60 tare. 2 into 30 this is 60 tare. 2 times 2 is 4 si tare. How is it? 900 ne 60 ne 60 ne 4 ne plus tawni side plus tawge 900 plus 60 plus 60 plus 4 si plus tawre 4 la e 12 la e 1 carry 1024 tare. Si plus tawre 1024 tare sida ire sida huji loire. Bab tarni ko se mathang Roman number 2 sisu manai se muk tawse. Now solution. 35 is equal to 35 ki square putho abani. 35 is same as 30 plus 5 whole square. Mamang ida tawdu main hoji tawrani. 30 plus 5 ta 30 plus 5 na multiply tawba. 30 na 30 plus 5 ta multiply tawba. Plus 5 na 30 plus 5 ta multiply tawba. 30 into 30 la ni. 30 into 5, 5 into 30, 5 into 5. 30 into 30 the 9,900 tare. 30 into 50 150. 5 into 30 is 150. 5 into 5 is 25. Howzik sigi number singsi plus taurani. 900 150 150 plus 25. 5 la 5 10 12 1 carry la 9 10 11 12 sitare. 1 2 2 5. This is the answer. See gyantarni ko. Roman number 3 mukta Roman number 3 semane. Solution. 86 square lani mamang da tawu maina 80 plus 6 thamani square lani 80 plus 6 into 80 plus 6 lani gyantari ko 80 na sige bracket multiply 80 plus 6 plus 6 na si 80 plus 6 ta mo multiply 80 into 80 lani 80 into 80 80 into 6 80 into 6 plus 6 into 80 lani 6 into 80 plus 6 into 6 lakani 8 are 64 0 ani hapsan gani 6 8 are 48 6 0 amasi hapsan le 6 8 are 48 0 amamo hapsan le 6 6 are 36 ilaya plus tawni 6 4 0 0 480 480 36 ka plus si plus tawre 6 8 to times 16 17 18 19 9 1 carry 4 8 12 13 la 1 carry 7 3 9 6 tare 7 3 9 6 ba tari ko sa si yani ko adu di Roman number 4 5 6 to manare adu gitu yum da practice toro mathang ki question number 2 se mu tawse se mu tawse question number 2 write a Pythagorean triplet whose one number is Roman 1 gi 6 question se ta hai si Pythagorean triplet putho aduga sida piriba number 6 ina Pythagorean triplet sing dugi marakta number amadu 6 ni ha badu di ngasai gi khoi na Pythagorean triplet ki tanggi badu ningsing asi for any m is greater than 1 sige se 2m m square minus 1 m square plus 1 form a Pythagorean triplet sigi sinarani se 2m ne m square minus 1 ne m square plus 1 ne और the m si hoji Roman 1 to the number 6 hai ne piram bado ado 6 to tahana ba 2 into 3 ne lakani 2 into 3 6 retar di m se 3 tarani aduna Roman number 1 da m si 3 lawrani aduga sigi 2m kya ta yengani m square minus 1 kya ta ge yengani m square plus 1 si kya ta ge yengani aduga Pythagorean triplet tu irani ba tare ko do di hoji hawrsi if m is greater than 1 to m square minus 1 m square plus 1 form a Pythagorean triplet masaki formula tu ni let the people to m sila asi let 2m is equal to masaki given number siga manhala ni 6 therefore m is equal to m puto kaya 2 na 6 divide ni 6 divided by 2 if 6 is divided by 2 then we are getting 3 then sigi m square minus 1 si kya ta ge ngasi m square minus 1 is equal to m से 3 ni 3 square minus 1 3 square is 9 minus 1. If we subtract, then we are getting 8. And siung putuasi m square plus 1 siung putuasi m square plus 1 is equal to m is 3 square plus 1 3 square is 9 plus 1 then the end is getting adu di hoji khoi pang 6 ne 2m sina 6 ne m square minus 1 na 8 ne m square plus 1 na 10 ne phange. Therefore the required Pythagorean triplet is 2m की value 6 m square minus 1 की 8 sigi m square plus 1 की 10 sitare. The required Pythagorean triplet is 6, 8 and 10. Sida loire. Roman number sida 2 laire 14 Roman number 3 laire Roman 4 laire Roman number 2 3 4 si manare aduna yumda practice tawro yani ko se bab tare ko. Okay, for today let's stop here. All of you, thank you.